Hi guys, in this video we're going to talk about reporting your results for the exploratory factor analysis. For thesis purposes, when you're writing your master thesis, would like to see, I don't mind seeing, and I hope that I can see exploratory factor analysis done separately and you report it separately than the measurement model. But here I am trying to write a paper with my students. So in this, for this purpose, I'm going to just put the exploratory factor analysis as a preparation step for the measurement model. You could also do that in your thesis. It is all up to you. So if you decide to do the same as I'm doing right now over here, it's also so much acceptable. So what is it that I'm doing here? So what I'm doing here in the measurement model is we are going to try to start with the Cronbach alpha and a Cronbach alpha reliability test. So even though the thesis usually will be based on very well established literature in most of the time, and the literature is very well known, and the questionnaire maybe is borrowed from other researchers. In the case you are using the same exact questions, you haven't changed any word in the questions, and you check the paper where you got the questions from, and the source shows clearly the Cronbach alpha and did clearly the exploratory factor analysis and all that, then you just say that I am not going to do this step because I haven't changed anything in the questions or in the wordings. With my very good student here, we have done some changing of the wording, and we added little some modules here into the theoretical model. In this case, we are going to work with exploratory factor analysis and report the detailed results of this exploratory factor analysis, starting with the Cronbach alpha. All right, because you have changed a little bit of the wording in the questionnaire and you haven't used the exact same thing, or you added an extra element to the constructs. In this case, this is how you start. You start with your Cronbach alpha and your exploratory factor analysis results, and you show that you understand what you're doing, and even though you have the well-established literature, but you actually would like to ensure the internal reliability. So this is what the Cronbach alpha is all about. It's about internal reliability, meaning that this question actually asks about one factor, pertains only to one factor, and it is also part of other factors answering one question, or referring or inferring to one construct, one factor. So usually in structural equation modeling, just a reminder, what we do is we have multiple questions. So in our case, this question is asking about one item, which is order risk 1, order risk 2, order risk 3. So I would like you all to be able to understand how to also report the coded variables. So in your Excel sheet, you would need, I have an Excel sheet, for example, over here for my data, somewhere in my folder. This is, for example, the data. I have another sheet in another data sheet where I have exactly the description. What is the description of order, risk, delivery time, and so forth. You can see here in Excel I have it coded differently, but I know that this is risk 1, this is risk 2, this is risk 3, and this is risk 4. So when you're writing your thesis, you need to explain what is risk 1 is, and you need to define it. And it is somewhere in my I probably have it in one of my files, in one of my videos, that I have showed you guys how to do this, and I called it the index, the indexing of the data. I wonder where I put that in, but this is something similar to this. So now I know that, for example, this is question 1, a question, and this is a question: how long delivery time is long, for example. This is order risk delivery time. Actually, this is risk 1, this is risk 2, risk 3, risk 4. But in Excel, I like to see a little bit of a meaning of what it is, so that I don't have to, while I'm doing the analysis, I don't have to refer back again to my this is just my style, but you could just do it risk 1 right from beginning. It's easier for you because you don't have to change the tables. Just copy from wherever source it is and paste it on Word, and it will be nice. But in my case, while I'm doing the analysis, I really would like to know the meaning. What is this one? I can infer that from the shortcut here, delivery time. This is safety, this is privacy, and this is return, and so forth, return policy. So, but when you're writing your thesis, would like to see it in this manner, okay? So now the first thing I think you need to show is your pattern matrix. Most of the papers don't show the pattern matrix, but I like to show my pattern matrix. And with the pattern matrix, you need to care for two very important things. First of all, that I showed you with one of my videos how to create this pattern matrix. Usually I like to start with the Pro Max rotation. So you need to explain here which software that you have used and which rotation method exactly that you've used, and also to show us the loadings over here. So what you need to show is that these are the factors that the system has automatically clustered, and we have factor 1, 2, 3, 4 uncovered. So that's good because we are looking at risk, order risk, affective trust, cognitive trust, and engagement. So we have 4 also different factors. So we are doing really good. We're not having more, we're not having less. And then you need to make sure that, of course, in the settings, you make sure that it is not, you suppress any loadings less than 0.33 or 0.3. But now you would like to make sure that all these questions that have the same meaning, which is all have the same theme, which is order risk, are loaded at one single factor, no matter it is 1, 2, 3, 4, and only one single factor. And it is better not to have double loadings. And if we have double loadings, it is the worst scenario is that this question over here is loading higher. For example, 0.9 on factor 2 with engagement, as if it is an engagement item rather than an order risk item. We as researchers, we could tolerate something like 0.3 over here, while here's 0.5, so it's loading higher on its expected factor. But it's still not very accepted easily. Yeah, I was lucky here because I don't have double loadings, as you can see, but I have some problems. I had this over here loading somewhere else. This is based on the literature. I wrote it as affective trust. It ended up being part of a risk. You know why? Because the question was that the negative comments and negative comments from the crowd, anything related to the crowd, we conceptualized it as affective trust. But negative comments, really, when you look into it deep inside, it's negative, it is risk. So this is why the system identified it here with risk. So I can understand that why the system identified it with risk. The same applies here. I still remember what the question was over here. Affective trust here, not with the crowd, but with the individual, with your Facebook friend that you don't know very well. Your Facebook friend you don't know very well is not necessarily trustworthy. It may be even considered as risk, and this is why it is loading on risk. But literature-wise, yeah, now what some of you might say, you know what, Professor, why don't we just take these items and rename them as risk 5 and risk 6, and we add them to this factor? First of all, do you have the literature backing for that? It's not only about mathematics and about numbers. There's a human being behind the screen, isn't it? And this human brain should have a judgment. This is backed by the literature that it is risk. Second, do you really need to do so? Even though you might see now in the future that my Cronbach alpha for order risk isn't that high. It is 0.69. There is a room for improvement, but well, you know what, guys, still I don't see there would be a coherence in my literature if I add these two just to risk and say, okay, I have a fancier scale, and I meant by them being risk and all that, and I don't like this falsification or fabrication. You just go by what science tells you to go by and the previous research tells you to do. So in this case, you can take a look at all the loadings. This is, I got lucky, I'm telling you. This is a very clean pattern matrix. Sometimes the pattern matrix isn't that clean. And now what I want to do is, first thing to do is to interpret what I found here. So the first interpretation is that I'm going to get rid and eliminate these two, effective trust 7 and effective trust 4, because they're loading somewhere else and I expect them to load here at this factor. So this is one thing that we need to do. Now, second, you need to take a look at the correlated item total correlation. What is a correlated item total correlation? Did I write anything about it? I didn't. Let me check. Find. Oh no, I don't have anything written on it. So maybe I should add this to my analysis. But this is one very important also thing that you need to produce. I haven't probably showed you how to do that in my previous videos. Let me see if I remember. I think you go for analyze and descriptive statistics. I forgot also explore, I think, for example, and you take all your variables here. This is positive comments, this is negative comments, no. We're gonna delete that, not a trusted friend, no. And now I'm gonna hit this just for you to see about outliers. And histogram here, normality here. We might need these tests for normality. I don't think this is where we get it. Oh, we get the collinearity statistics here. So leave this. It's something that we might need. Shortly, I want to show you a little bit about multivariate collinearity as well. Okay, so it's not here really, right? Is it? This is not where we get it, huh? Okay, I forgot where we get it. This is all collinearity. What? How do we get it? I did the explore, right? Let's do the frequencies this time. So there are two main. You know, guys, I self-taught myself this program, so bear with me sometimes. Over here, you get also the skewness and the kurtosis, which is other measures of normality. Let me check anything else. Charts, maybe histogram, and show the normal and make sure that this is checked. Format, suppress labels. Nothing here to change, and okay. It's gonna take a while to produce results. So over here also you can get all the images. You don't need to do it with Excel. So last video I showed you how to do it with Excel. If you have SPSS and you wanna just take it as is, over here this is the name of the variable, and this is even there's a mean and there's standard deviation here. Even though all this for me as a person who knows a little statistics, when you have a discrete measure like that, is not even continuous. You have 1, 2, 3, 4, 5, only the answers, they are not continuous. with social science research, they overlook the idea that these are not continuous data, and they treat it as if it's continuous data, and they continue to draw a normal distribution on top of it as if it's a histogram, and they also go farther to find the mean rather than the median. And because the median is already known here, you can see it easily in the graph. So they go further to extract the mean here. Okay, where's the... I'm gonna hit find and see if I'm gonna be lucky. Find total correlation. No. Okay. Seems like I kind of forgot where to get the total correlation. I'm gonna make it in another video. But what I just showed you right now is different checks and tests for normality that we're gonna jump into it shortly. In any case, there's something called correlated item total correlation. I'm going to show you how I got it. In fact, I can show you just right away, because I remember just now that okay, I have it over here. Just hang in with me. What is this? No. Okay, I'm sorry for that. Maybe I should just trim this video, getting so long looking for something that is not there, but I'm sure, I kind of sure that you can. I saved it somewhere. It was in a PDF that I put together. Here. Now we know it's under reliability analysis, because it's part of reliability analysis. I don't know how I forgot that. So it is under reliability analysis. So if you do a reliability analysis, you go to analyze, scale, and reliabilities, and then let's do it together. Now that I remember. So you go to analyze and you go to reliability analysis. It's under scale. So under scale, there's reliability analysis, and then you throw in there all your variables that you're investigating. In my case over here, I don't need the negative comments, as I told you, and we're going to get rid of this as well. And now you can statistics, make sure that if you wanna check, for example, here the scale and scales of item deleted, you can check these. Continue and hit OK, and now all the variables have a Cronbach alpha of 0.78, so that's really good. And this is the item total statistics, and this is the correlated item total correlation. So that's awesome, isn't it? So here the correlated item total correlation, as you can see, these are the correlations. Any correlation below 0.2 is problematic. So we have here this problem here with cognitive trust 2. I know it's 2 because of these two here, and this is below 2, so I had to delete that. I had to eliminate that. So this is how I got the from the reliability here. I got the reliability for all the variables. The whole model together is 0.781. But usually I will want to do this the first time just to get these items, the correlated item total correlation. I suggest for my students from experience that you show your pattern matrix as is. The first elimination that could happen is an elimination because of loadings elsewhere. The second elimination then that could happen is due to the fact that your correlated item total correlations, meaning the item is relevant to and highly correlated to others. It should be correlated to others. If it's not, then it's a problem, isn't it? So over here, as you can see, I have a very low cognitive trust correlation. By the way, these findings were even before I cleaned the data. So if you've noticed, probably you're watching my video very attentively, you probably noticed that maybe the number is not the same. Here's 187 and here's one, I reported it as 177. This is before I clean the data further. I'm gonna go into the discussion with you in a bit. But still it is below 2. In fact, if I found out right now with my clean data that it's not below 2, because you can tell that if you clean the data, and I'm going to tell you how, there's another data cleaning that you should also undergo before you start your measurement model. You probably, it's worth it checking again because it seems like it's gotten higher. Maybe if I clean the data a little bit, I probably wouldn't have to get rid of this factor, of this item. So it's always worth going back and checking. So this is what happened. I then got this and I got it under the analysis, scale, reliability. And then over here, I decided also I'm gonna let go of this item because it has a very low correlated in item total correlation. It's not very highly correlated with the other items. So as you can see here, this is how this is 2 steps of elimination. Then after elimination, I ran the analysis again after getting rid of this and getting rid mostly of this. I ran the analysis and this. I ran the analysis again, the factor analysis, and I got new loadings. As you can see, the loadings in most items are higher now. Doesn't make really big sense, big difference, but as you can see here, there is a total variance explained. I like to report it in the bottom, before and after. So after the elimination, either by eliminating for discriminant validity here or over here as well, then it's good to take a look at your total variance explained. And just a reminder, how do we get that? If you guys remember, this is where we do the factor analysis. So you take all your variables here, right? And just 1 second, in my case, I just need to constantly remember. And then extraction, make sure it is on the eigenvalue, and KMO, and then rotation, I suggest the Promax or the Varimax. See which one works best for you. Options is suppress anything below 3 or 3.3, up to you. I'm just gonna put it 3 for now. And then here is the analysis. So you start reporting your analysis here. But in this table, the table that I showed you, this is where you get the total variance explained. The total variance explained is the cumulative percentage here. And over here it's 61.319. This is the data after cleaning. I wonder, I cleaned it on in multiple steps. So I cleaned the data in multiple steps. In any case, let me check. This is not the, let me just double check. 0.63534. Yeah, there are little discrepancies. I think that this data file that I'm opening right now is not the latest one. It's not the latest cleaning data file. And I'm going to show you in a bit. I need to make sure that I have all my data cleaned up nicely. And also make sure that you always save these files. So I have names for them, and I have I have the names for the SPSS and the AMOS. I should look into my data again and make sure that $215. Oh, this is the latest clean data. Okay, I need to check what's going on. Anyway, so please double check because errors can happen. So double check your your analysis. So this is your total variance explained, and you need to report that in here. And then this is the keep this saved because you will come back to this. You would need to then talk about the KMO. You're here where you started with the factor analysis here. So you need to report your, go ahead and report your KMO, and so over here you reported after deletion of the variables. And oh, wait a minute, you know, these results, I haven't deleted the cognitive trust too. You see, it's still there. You see that? You see that? It's still there. This is why I have different readings. So take a look. I just wanted to make sure that what I've been doing last night is not gone for waste. And I have to go back again. And this one, cognitive trust, TC2, we decided to get rid of it because of the internal correlation is very low. So over here, let's take a look. Yeah, now it is consistent, 62.374. 62.374. Perfect. So I forgot to get rid and eliminate the cognitive trust 2. Now when I eliminated it, this is the answer I got, and these are the loadings exactly. I put them there. And also I here, as you can see, let me show you guys so that it's easy for you and like a piece of cake how to report the results. You can start saying that the Kaiser-Meyer Alkin measure of sampling adequacy is over 0.7. Actually, it is approaching 0.8, so it's quite reliable here. You can just say it is approaching 0.8, and the chi-square for the Bartlett's test of sphericity is this amount, is this magnitude with degrees of freedom. DF is degrees of freedom of 120. Significant level is below 0.001, so it's significant. So I said the test of sphericity here is significant, and I put the significance level, and with a value of this much, the chi-squared, for this much degrees of freedom. And the total variance explained was over 50%. In my case, I could even say over a bit over 60%, with total value of 62.37. And the results confirmed 4 main latent factors, and they are all the loadings of their items, with item loadings over 0.3. Now let's take a look at another. So the first reliability test here was done per item, which is the item total correlation, and I put it here, guys, because it may play part in elimination. When it's below 0.2, then it is alarming. Bestest thing is over 0.4. Some of my items are over 0.4, but I do have items, gladly that most of my items are over 0.2. As you can see, I told you that I cleaned my data, and I will show you how now in a bit, and it yielded a higher value over here. Maybe if I have some time, and I should probably clean the data a little bit more, and maybe I will get, I remember I ran the analysis with you now, and it was 0.18, a little bit higher. So maybe I can get to that 0.2 threshold and keep it. I'm not sure. I will check. It's worth investigating, in fact. Even though I'm going to spend a little bit more time to do it, I may be willing to do it. I would do it. In any case, this is research. So the psychometric properties of our constructs were assessed by the reliability test of the Cronbach alpha coefficient. So here I constructed this very lovely table, very important one, that reports the Cronbach alpha for each factor, for each latent variable, and then the eigenvalue and the total variance explained. Where did I get all that? I got the total variance explained from my factor analysis output. Now we got rid of, we finished this. This is nothing but squaring the loadings. Here, this is the initial eigenvalues. These are the eigenvalues of the first four factors. These are the factors that really matter. And by the way, if your cumulative percentage or cumulative percentage of the variance explained is below 50, some cases they say below 60 even. So like some editors might be like, no, below 60 is even below 60 is really bad. Others might say, okay, around 50, higher than 50 is okay. But in general, if you have anything above 60, you are good. Above 70, you are even better. So the higher, the better. Okay. And the bestest is something above 60. All right. Not the bestest, but a very good threshold that is not very highly refuted is the 60%. The 70% mark, oh man, this is great. Anyway, these are the eigenvalues. Make sure that on a little notebook that you have, as I do always, I write here that one in the system is here effective trust. All these guys are actually effective trust. Number, where is the pattern matrix? This is one in the pattern matrix is effective trust. Number 2 is engagement. Number 3 is cognitive trust. Number 4 is order risk. So now I have them ordered on my notebook. Where's my notebook? It's right there. All right. So now I have them ordered and written on my notebook. I can easily report the results. So this eigenvalue corresponds to effective trust. This is 2 engagement. 3 is cognitive trust, and lastly is risk. So you can see here's the eigenvalues and here's the variance explained. It's the same here really. So here's the variance explained, and you can just line them up nicely as you can see over here. All right. Now where did I get the Cronbach alpha over here? If you remember, when we ran the analysis earlier, when we wanted to get the correlation, the total item correlation over here, the correlated item total correlation, the item total correlation, we got some Cronbach alpha, but for all variables. This is something different. We could actually take note of it and report it, but I don't see papers reporting that often. However, what we do is basically you go to analyze, and I have it in another video, but it's okay, I'm going to do it again. And you go to scale, you go to reliability, and you focus on all the factors that reduced with elimination of anything that needs to be eliminated. So the latest, the final structure that you have, and don't forget to not give it a label. Please always give it a label. So put it as order risk and hit OK. And then you will get the reliability test for order risk alone. And that would be, as you can see here, Cronbach alpha 0.694. I got lucky, it's on the edge, 0.69. Some research papers reference also other research papers saying that 0.6 is all right as a threshold, but some editors, if you're publishing your work, some editors might refute this. So 0.7 is very difficult to refute. It's kind of very good measure. I got lucky here because I have 0.69. So I'm gonna try to actually clean my data a little bit better. There's some data maybe needs to be cleaned, and I will show you now in a bit by the end of this this video, how and why. And then maybe I can get a better Cronbach alpha. But here I am quite, I don't think, it's quite a pain in the butt if somebody comes and say, oh, this is not 0.7. It is so close. It is 0.694. It's quite close. So I think it's acceptable to my taste, to my understanding. It is acceptable. It's not food to my taste, but to my understanding, it is acceptable. Let's take a look at the second one. You will see very nice results here, I think. And over here, we need to get rid of this one. And don't forget to give it a name, which is here effective trust. And then here you can see, I know that AT is effective trust, and here my Cronbach alpha is over 0.8. In fact, you can see here all my Cronbach alpha is 0.69, 0.8, 0.8, 0.7. And I have to admit that these numbers were way less before I deleted 10 data points that found to be influential. And this is the next step. So, do you see why this analysis is confusing? I hope that you now see so. Now, Nora told you, I told you here, okay, you know what? Here you do the factor analysis, you do the correlation, you delete these, but actually the data that I ran this analysis on also was 2025, and over here, and then I ran it again on 225. What I want to say is I ran the analysis on 225 data points. I got this, then I eliminated everything and I got this on 225. And I even did this on 225 points. Then I proceeded to the next step that I'm going to explain to you, which has to do with the multivariate normality and multivariate normality and multivariate outliers. Now, started cleaning the multivariate outliers using what we call it where do I have it? I don't even have it here, but it is using the Mahalanobis distance. Somewhere it's here, the Mahalanobis distance. And then I said to myself, all right, I can see that over here I'm getting very good results. Let me run the analysis again. I ran the analysis again and I got better results here in this analysis. Always report the good part. In your thesis, it is not bad to report as is and then say, after cleaning the data with the Mahalanobis distance, clean the multivariate outliers. After cleaning the multivariate outliers, I even got better results, and this is my final results. You can do that in your thesis. But if we are writing a scientific paper, a paper for a journal, it is a lot of hassle to do that. So I'm gonna just put this here, the best of the best readings. It's not a thesis, right? It's a journal paper. So in your thesis, you can tell me the steps and what you've done. But over here, I'm gonna just report the best findings that we got, and even I'm gonna try after this video to clean my data further, in fact. And if I can find here that this is almost approaching to 2, I'm just gonna say that I cleaned the data first. So I'm gonna mention here cleaning the data first based on the multivariate outliers. First, I checked them and cleaned them first, and then I ran the analysis, and this is the results. You got my point? Actually, this is the way I should be writing, but for you guys, it's going to be confusing because here I am teaching you step by step. Once you are a pro, once you're mastering this, you will understand that this research is not like a rain shed or a waterfall. A waterfall kind of approach is not like step 1. Fall to step 2, fall to step 3, fall to step 4. It's more of a looping, a circle. So you need to do these steps first and then go ahead and do this step that I'm gonna cover in the next video. And then if you do this step, it is not a bad idea, especially if you need to improve anything here. I needed to improve some readings over here. My readings here, for example, for my multivariate assumption was not meeting the assumption. If you don't meet the assumption, it's not the end of the world. You have to go and check the outliers. This is why we need data cleaning. And then you clean you might tell me we need to clean the outliers first. I tell you, yes, you might be sure. We need to, you are right, we need to clean the outliers first, but I haven't covered this yet with you. So this is why I'm going to report it to you step by step in such a way that you digest it. So now we clean the outliers, and this is a very good, interesting video, the next video, where you can see how outliers can actually affect your multivariate assumption. And also I can see here that it is also affecting from experience here, it's affecting also the item total correlation. It might improve the item total correlation. So let me meet you then in the next video. But before I leave, I'm going to summarize everything we've done. So we've done the factor analysis. And factor analysis, we do that by analyze, dimension reduction, factor. We usually do the extraction with the eigen value, pro max, I like it, or very max. And be careful, you need the options to suppress anything below 3. Then you got these analysis, you start with the reporting, and the reporting here starts with the KMO. So with the KMO, it should be significant, your factor analysis, preferably over 0.7, 0.8 is awesome. This is approaching 0.8. Report everything in this table. Then in another, then reported in the paragraph. Then you have 2 tables to report. The first one is this, the pattern matrix. So you report this pattern matrix, and you report its total variance explained, which is over here at the last factor, which is, it happened to be for me 62 point something. Then in this table, this is the first table, right? Then in this table, wait for it and continue with this table, since you have it already open, and just continue with the total variance explained for each factor and the eigenvalue. All right? Sorry, this is just music. Where I've been here. So we have total variance explained over here for each factor. Sorry, item is the item that you ask in the questionnaire. It's each question, we call it an item, but over here it's a factor. It's a latent variable. So then you report this and the eigenvalue. Good. Now you have 2 things to work on. Still, both of these aren't complete. This is completed, but this is not completed yet, the Cronbach alpha, and this is we haven't completed yet. So these we complete them, this and this, with the reliability analysis. Now I remember carefully and clearly. So you go to analyze, and you go to scale, you go to reliability. The first thing you do, you probably gonna work with all the variables at once. You remember what we've done? We've done all the variables at once. So all these variables, we took them together. Sorry, what a waste of time. We took all these variables together. I need to take out some of them, right? And we hit OK. And this way we got the reliability for everything. And then we got what is called correlated item total correlation. Be careful. When I ran this analysis, I did not eliminate any of the variables. This is a mistake. I'm just summarizing for you. You need to eliminate the variables from this step. So you need to eliminate here 2 items from this step. I didn't eliminate them right now very quickly, but you need to eliminate if there is anything that needed to be eliminated. We talked about why we eliminated these and eliminated these, sorry. We eliminated them because they are loading elsewhere, all right? Or they don't have any loading anywhere. So if there is a variable that 0, 0, 0, 0 is just blank, its loading is less than 0.3, which is the cutoff value. We're gonna eliminate that altogether. So from there, you can get the item correlation. Anything below 0.2 is criminal, is no good. So you need to get rid of that. However, from experience, I found out when we clean the data with the Mahalanobis distance, you might get a better reading. So sleep on it and keep in mind that you might revisit this analysis again. So don't make everything fancy on Word document. Just copy whatever you got here in an Excel sheet. Yeah, just copy that, right click and copy and put it in an Excel sheet and name it item total statistics and all that. And wait until you proceed to the next step, yeah, and get the analysis, make sure everything is there you're satisfied with, and then if everything is you're satisfied with right from the beginning, then go ahead and report everything and make the tables fancy on Word. If not, and you have to do some fixing for outliers, and this is most of the time we do the multivariate outliers check, then you might have to do it and redo the analysis you've done up there again. So my advice is not to do anything as of now and wait for the next video so you learn more and you start to probably you can't actually, this is the thing, if you start over here with multivariate outliers check, you will not know about these factors being eliminated, right or wrong. So this is a problem. You don't know that these factors needs to be eliminated, and this might also affect this step. So this is what I tell you about this kind of analysis needs a little bit of perseverance. You don't need to give up very easily. You don't give up very easily, and be persevere and patient. Be a little bit patient, yeah? And take your break and come back. All right, so now that you've done this, the last step was to find these values. That now you got these and you checked everything is all right. If everything is all right, then everything is all right. If not everything is all right, then eliminate these two and then run the analysis again. Good, good. All right, in fact, I ran the analysis after my multivariate cleaning, which I'm gonna restructure all this and start and write over here about the multivariate cleaning of my data before even I refer to the table. So this is the best practice, but it's okay. I wanted to make videos that has consistent meanings, and this is why I put it for now under the multivariate normality and multivariate outliers check, which is something we're going to cover in the next video.